Hello and welcome. In today's video, we're going to cover Chapter 2, Networking today, in the CCNA Introduction to Networks curriculum. So this CCNA is part 1 CCNA. So there are 3 parts in the CCNA curriculum that we're going to mention. There will be 3 courses, 3 separate courses that actually will allow you to prepare for CCNA exam 200-301. So let's actually start with an overview of networking and understanding a couple of things related to networking and computer networks. So the objectives in this chapter, things that we're going to learn, is we're going to define what is computer network. Okay, some of you might have been working in IT field as network administrators or engineers for many years, but they want to achieve a certificate. Some of you are beginners, so I'm addressing the beginners. So you need to know the basic concepts of networks. What is the network components, network representation, topologies, common type of networks, internet connection, reliable networks, network security, brief overview of security. We're not going to dig deeper into it. And then finally, we're going to talk about the IT professional. What are the available jobs as network engineer or an IT technician, and so on and so forth. So let's get started. So, as you may know, computer network is a interconnected devices that can communicate together in order to share resources. So the main function of the network is to share resources and enable users to access services and access devices and so on and so forth. The resources could be file sharing, instant messaging, could be printing, and so on and so forth. So network components. So in the network components, we have 3 types of components. We have the network devices, as you can see here. We have networking devices. Let me grab my pen. So networking devices basically mainly are the routers and switches. So the routers, they actually forward packets based on destination IP address. Okay, they build routing tables. We're gonna talk about this later on. Okay, when we get into routing, switches basically what they do. At least layer 2 switches. I'm gonna use some techie terms, but don't worry for now. We will actually talk about layer 2, layer 3, which is those terms and concepts. We need to master them in order to achieve the CCNA. So layer 2 switches, basically, they forward frames based on destination MAC address. And then we have the end devices. The end devices are any device that provide the user with graphical user interface. It could be PC, it could be laptop, it could be a smartphone, a server, all the devices that actually the user, interact with. It's called an end device. So in order to connect all those devices, the internetworking devices or networking devices with the end devices, we need some type of media. Okay, so as you can see in the diagram here, we have a LAN, local area network, okay, that have a couple of end devices and networking devices. As you can see, we have a switch, and then we have end devices connecting to the switch, and we have a couple of users that are accessing, those devices as well as in the internet. Here we have the WAN connection. Okay, we have the WAN connection allowing the LANs to communicate together. So we have 2 LANs, and then we have the internet in the middle. So the end devices is where the messages, or the message originates from, or where it's received. So the message is received or originated from the end device. So next slide. Network components, continued. So we could also call them intermediary devices. So intermediary device or networking device, we are going to use this term interchangeably during this course. So intermediary, the devices that sits in the middle, enable communication between the end devices. And in this topology, as you can see, we're going to use those icons in Packet Tracer. If you are not familiar with Packet Tracer, what is Packet Tracer? So we're going to get there. I'm going to show you how to install Packet Tracer, how to download it, how to install it, and how to use Packet Tracer for lab environment and for practice. So yeah, we're going to use those icons, as you can see. So wireless router, we have LAN switch here. We have a router, a firewall, multi-layer switches. So we're going to get into these icons that we're going to use in Packet Tracer later on in this course. And then we talked about media. So we have the internetworking devices, we have end devices, and then we need some type of connection to connect the end devices with the internetworking devices, and that's the media. Media could be copper cabling, as you can see, like Ethernet cabling, Cat5e, Cat5, 7, 8, and so on. Or could be fiber optic cabling, as you can see. Or could be wireless that use radio waves. Fiber optic basically uses a light that travel into the laser glass. Okay, so let's move to next slide. Network representation and topology. So as network administrators and engineers, we are gonna need to learn and also document, our networks. So we keep a map, full map of the entire network. And in order to do that, you need to have a physical and logical topology that I'm going to show you after this slide right here. So those are the icons that we're going to use in Packet Tracer. So we have the end devices, including PCs, desktops, laptops, printers, IP phones, wireless tablets. Then we have intermediary devices or networking devices, routers, switches, wireless access points, multi-layer switches, and so on and so forth. And then we have the media, we have wireless media, we have LAN media, and then we have a serial connection, in the WAN connection. So in the next slide, we're going to talk about the types of topologies. So as a network engineer, you need to keep in mind and you need to know how to design, the network topologies. The physical topology. Physical topology basically involves all the server layouts, how the servers are actually installed in the rack, for example, the rack number, the shelf number in the rack, and then the host name, for example. So you keep this electronically using Microsoft Visio or using Glyph diagram, or some type of diagramming. There are a lot of software out there to keep sorry, to keep the topology electronic, and you need to update it whenever you need, and so on. So the logical topology, basically, it's the host names, the interfaces of the devices, and the IP addresses. So in case you want to, for example, SSH or Telnet to a device, you need to know what device name and what IP address, and probably other information like the interface, which is gig01 or gig00, and so on and so forth. Common network types. So we have different network types. As you can see, we have a network could be small, for example, small home, or small office, home office. This type of network, actually, you need one router and probably a switch. It's less than 25 devices, small office, home office. Then we are we can have medium to large networks. Those are the 200 devices. Medium large network is 200 devices and beyond that number. Worldwide network is basically the internet. So the internet is, as you can see, businesses, schools, ISPs that are connected together. That's the worldwide network or the internet. Common types of networks, LANs and WANs. So we have different type of network, like the LAN, for example, a home office, connected with a branch office. The home office could be located in US, for example. The branch office could be located in UK, and then the central could be located in Japan, for example. And then we have the cloud or the internet that is allowing the communication to happen between all those branches and main offices, as you can see right here. So the LAN, local area network, the term basically refers to a device connection of devices or interconnected devices that are in close geographic location. Could be home, could be office, hospital, university, campus, and so on. The internet is basically a gigantic web of form, connection of routers that are actually in ISPs that are connected together and allowing businesses to communicate and connect to each other. And the WAN stands for the wide area network. So the definition of the WAN is a interconnected devices in a long geographical distances. That's the WAN. So we need to learn the term LAN and the WAN. LAN and the WAN, we need to master the difference between them, and we need to know what is the LAN and what is the WAN. Common types of the networks, LAN and WANs, as you can see. So this is a LAN, local area network. As you can see, a couple of users, PC servers that are connected to a switch. We could have a router that is connecting us to the internet. That's a LAN. And then we have two LANs here connected via the WAN. The WAN connection basically is from the demarcation point. For example, it could be home. So this is the U router, the customer premises router. And then after the customer premises comes the WAN. So here it starts the responsibility of the ISP or the internet service provider. Internet connection. So basically the internet, the definition of the internet first, let me actually show you what is the internet. So I'm going to bring my command line and use CMD. So as you can see here, I'm launching a CMD window. So what I'm going to do here, I'm going to use tracer-T, to trace the path to Google server, as you can see here. And then I'm going to show you the concept of the internet. So as you can see here in the this column, it's called hop count. So this column right here is called hop count. So each hop is a router. Each hop is a router. So let's see how many routers we are going to actually pass or cross to get to the Google server, and that's the internet basically. So as you can see, as I'm located in Iceland, this is my default gateway, my router, and then we're using another IP of the ISP. It's private IP, as you can see, and then we're still here in Iceland. As you can see, this is my ISP service provider, and then we're getting out of Iceland. No, still we are still in Iceland, as you can see. it's connecting to Siemen. So I think Ringde, the ISP, is connecting to another ISP, the bigger ISP, and then we are actually leaving Iceland right now, and those are all routers. So 11 routers in order to get to the Google server. Okay, so that's the concept of the internet. The internet is a gigantic, it's connection of routers located in ISPs in a gigantic form of web. Okay, that's the internet. Okay, so yeah, I just want to mention something. We're gonna use the trace route on Windows, trace route on Cisco iOS later on, and on Linux, Unix. Trace30 is used in Windows to trace the path, and also it's a very handy troubleshooting tool. We're gonna use it for troubleshooting because actually it traces the path, and also it tells you where the problem exists, so you could escalate troubleshooting problems. So let's move on. So we have different types of the internet subscriptions, or connections. So we have DSL, which is the most common type of internet connection. The DSL have different flavors like VDSL, ADSL, and so on and so forth. And then we have cable. Cable is kind of deprecated. Okay, it uses cable TV to carry data. And then we have the cellular. Cellular is more popular also, so it could use towers, to enable mobile devices to communicate using GSM core and using cellular towers. And then we have satellites. Satellites mainly is used in rural areas where there is no infrastructure for running cables and so on and so forth. So they use satellite, which is low bandwidth, connection used in rural areas. And dial-up, of course, it's deprecated, phased away. It's you dial a number and then you get a internet connection. Reliable networks. So reliable networks, first we need to understand what is reliability. So reliability is how many or how much downtime, during the year. So reliable network is characterized by there is no downtime, At least there is no, less downtime. Because there are companies that are not tolerant to any downtime. For example, eBay and Amazon, e-businesses, they cannot tolerate even 1 second of downtime. And that's why they need to achieve reliability. And to achieve reliability, we need to achieve 4 things. The first one is fault tolerance. So to achieve fault tolerance, what we need, instead of using a single point of failure, let's say here we have let's say this is a switch. And then let's say here we have a server connected to the switch, and the switch is connected to a router here. And then the router is connecting to some ISP, some type of ISP here, So yeah, excuse my writing, so you get the idea. If the switch goes down, in this case, if the switch goes down, then the network goes down. If the router goes down, the entire network will go, of course, down, So this case, we have a single point of failure. So at each layer, the access layer here, as you can see, we have a single point of failure. So to mitigate this problem or to overcome this issue, we need to add another switch right here, And then we could connect those switches. We could actually enable port bundling or port channel between them. And then we connect the server to the second switch. So this could be SW1, this could be SW2, and then if we go redundant, then we need to go redundant all the way. So instead of using one router, R1 here, and we add a second router, let's say R2. We connect the routers together, and then we connect the switches together like this. So this way, we have at the access layer, we have redundancy. So if this switch goes down, the other one will back it up. If R1 goes down, the R2 goes, okay, be the active router and start, okay, forwarding the data. Also, as I mentioned, we need to go redundant all the way. So here we have the ISP1, and then here we might have connection to a second ISP, okay? So this is the second ISP, this is the first ISP or ISP1. So if the entire ISP goes down, we still have a connection to the second ISP, and that's fault tolerance by, okay, using redundancy. So redundancy in a network is always a good thing to do. The second thing is scalability. So to achieve reliability, we need to have fault tolerance, we need to have scalability. Scalability means we can add devices and remove devices without causing any downtime. So we could just go here and then add another switch, okay, connect it to the SW1 switch, and then we could actually connect the server to the switch, no worries. If we want to remove this one, we could add a switch like this right here, and then, okay, we could schedule maintenance window. We could cable, okay, the server to the switch, and then schedule maintenance window, okay, after midnight, and then we could connect, okay, the switch to all the other devices, as you can see right here. The switch is pre-configured, you just install it, cable it, and then you are good to go, and that's scalability. Quality of service. Quality of service is a very important concept. QoS, so you need to prioritize traffic. If you have, especially for voice over IP and video traffic, in general, all real-time applications like video and voice are sensitive to delay and jitter. The delay is the amount of time that the packet will take from a source, okay, to a destination. Okay, that's the amount of delay. And you need to prioritize traffic, as I mentioned. So you need to tell the switch, okay, okay, this traffic is coming from an IP phone, okay? This traffic is coming from IP phone, so I need to forward it as fast as possible. The FTP traffic, HTTP traffic might wait, okay, that's fine. It could be in the queue, wait, that's okay. But the voice over IP and video, they are not actually tolerant to delay and jitter. That's why you need to implement quality of service. So you tell the switch, okay, on this port, on this specific port, you are connected to an IP, voice over IP phone, or you're connected to telepresence device. So you need to send this traffic as fast as possible. And then security, okay, so we need to a brief overview of security. You need to secure your network by implementing defense in depth, using VPN, encryption, using firewalls, doing access lists, and authentication servers, login, and so on and so forth. So we're going to talk about security later on. Reliable networks, fault tolerance. So I mentioned this in detail, as you can see. So to achieve fault tolerance, you need to implement what is called redundancy. So as you can see, so instead of one router, if one goes down, then we have a second router that will back it up. Even we have two different paths. So one goes this way and the second one goes this way. So if this router, even the entire router goes down, we still have a backup path to the internet. Okay, some companies, they might have different connection. It's called dual-homed, okay, connection to another ISP. So this ISP1, this could be ISP2, okay, and so on and so forth. At the access layer also, if we have like running servers, then we need to connect the switches together, use Ether channel between them, and then you could connect the switch to both the server, to both switches, and then you have, okay, two paths, okay, to reach the internet. So let's move, okay, forward. Scalability, as I mentioned, removing, adding devices without causing any downtime. Quality of service, implementing quality of service. If you have voice over IP phones, then you need to tell the switch, hey, you are connected to a voice over IP device, so send the traffic of this device as fast as possible. It's voice over IP. So, yeah. So that's it for the chapter. So we discussed the overview of networking. We discussed the networking components. What are the components? Networking components basically are the internetworking devices or networking devices or intermediary devices. I'm using the term interchangeably. And then the end devices, those are provide the user with graphical user interface or probably a terminal window. The user can interact with them. They originate the message and then they receive the message at the end. In order to connect those devices, we need media, some type of media, either fiber optic, Ethernet cabling, copper, or we could use wireless. So yeah, I think we covered pretty much everything. So I hope this has been informative for you, and I would like to thank you for viewing.